Okay, this is problem 8.1a from your first practice exam. I know it looks really bad and scary because of this coefficient here, but I promise it's not too horrible. So it's asking you to find the minimum radius of convergence. And if you remember from the lecture, the way you do that is you find all of the singular points, and the one with the shortest distance from the center of your power series gives you the minimum radius of convergence for that power series. So do please note that this series is centered at x equals 1, not at the origin. So keep an eye out for that. So we're looking for the zeros of this leading coefficient factor right here. And the reason we are is because when we put it into standard form, meaning we divide our y prime term and our y term by this big long coefficient here, the zeros of this first coefficient will cause division by 0 on the next two terms, which obviously is a big no-no. Division by 0 make the whole series pretty much explode. So we really want to avoid that at all costs, if possible. Okay, so finding the zeros is actually not too horrible in this one because Dr. Noring provided them for you. Right here at the bottom. So hopefully this problem won't be too horrible on your exam. So I went ahead and plotted them on the complex plane. For those of you who aren't familiar with the complex plane, your x-axis here is going to be your real axis. So that's where you're going to plot the 4 and the -5. For your complex numbers, you do have them in the general format of a plus bi. So the a in this scenario is actually a real number. So your -1 in both sets here are going to be plotted on the real axis, so your x-axis. So you plot both here. And then for the y component, you do the plus 3i and the -3i. So that's where you get these 2 points. So the rest of the problem is pretty much just deciding the distance from the center of your power series. So we have x equals 1 here, and then x equals 4 here. So the difference between the 4 and the 1 is 3. So we have 4, 0 with a distance of 3. So similarly, we can do the same with the -5. So -5 and 1, -5 here, gives you a distance of 6. So we have -5, that's the 5, 0 gives you a distance of 6. So to get the distances for the complex numbers, we're going to use a Pythagorean method. So we know that the distance between x equals +1 and x equals -1 is 2. We'll go ahead and square that, and then plus our distance here is 3 in both scenarios. 3 squared, and that will equal the distance squared for both of these complex numbers. So this goes to the square root of 13 equals d for both of those complex numbers, both those zeros. So the square root of 13 is approximately 3.61. So you really just need to know that it is larger than 3. So we have our -1, 3i, and our, nope, nope, don't do it again. Okay. If you guys can tell, I am not very experienced with this, but I'm doing my best, so we'll see how it goes. Okay, so back where we were, the square root of 13 is obviously bigger than our 3. So this tells us that our minimum radius of convergence is 3. And to reiterate, we found that by finding the zeros of this function here, because that's what causes your series to explode, because it causes division by 0. So it creates these little points over here that don't really work. They're bad for your power series, and we want to avoid them if at all possible. So I hope that made sense. If you have any questions at all, please let me know. I know that the online aspect of this class is going to be annoying, but I'm going to try my best to help you guys the best I can, and let me know if there's any way I can do that better.